Hello, and welcome to the first installment of the Cedar Rapids Area Homeschools IT Club. It's too cold outside, let's do homework. So this is the Morse code uh, interpreter program, which we will be discussing, in which I have asked you to look through. There's a lot of good stuff in here, and let's get it going. FYI, my recording software only allows me to take a up to 10-minute video, so this will be slightly abridged and will not be well monetized. Imports, yay, we know about those. Now, the first place I'd recommend starting is this Wikipedia page here, which just kind of details what all this information is, and how Morse code works, which is important. The only thing that's not on there is this stop code, which is specific to this program and does not exist in real life Morse code, and we'll see that later. We have our button and LED pin setup here for the Raspberry Pi. I'm going to skip down here to the bottom. So the only line of code in this file here that is actually going to run at first is this main function call down here, which I've got all my main code inside of here, and talked about this briefly last club, and it's a good idea. So just going to step through this first and then go into a little bit more detail on the functions themselves. So here we have just print some welcome instructions, and then we call listen for delays, which is going to actually wait for you to press the button and record how long you press the button for, and then how long you release it for, and how long you press it, and how long you release it, and the such. And then we're going to take all of that information and give it to the interpret delays function, which will actually take those timestamps that we got, and it will figure out what are the dits and dots and dashes, and then once it has figured that out, it will pass that to this decode function, which the decode function takes a bunch of dits and das, a bunch of Morse code, and turns it into English or Latin characters. So going up to listen for delays, which is the first function we call. It has no parameter because the input is going to be from the button. And I have some verbose commentary in here that you can read through, and it has kind of some example stuff. The first thing we do is we wait until you first press the button, and then one major thing, we're going to start the timer, and then we come down here, and we're just kind of going to keep looping until we see the stop code. At every time we come around the loop, we update our timer value to keep a current status of what our delay is, and then we check the button and update what state we currently see it in, whether pressed or unpressed. To explain what I mean when I say state change, is the button either going from pressed to unpressed or unpressed to pressed. So whenever it changes. The major comparison in this is we're looking at what did we previously see on the button and what are we now seeing on the button. And if those are different, then we have encountered a state change. And so then we will stick the current delay that we have recorded into the list, reset the timer, resetting the delay, and then loop back around and wait for more presses. Else, this is where we check for the stop code if there was not a state change, and instead if the delay is greater than stop and we have it pressed down, then it will, that we have received the stop code. This will get set to true, break out of the loop. And this is just trimming off the last delay that we have. You can figure out why we want to do that. And then we return all those delays that we collected. So that is the listen for delays function. And then down here we have interpret delays. And this is going to take in the delay list that we generated. And then it's going to output a list of strings, where each string is a Morse code word, and then those strings also have separate letters in them, separated by little slashes. So what we're doing here is we're just looping through each delay in the delay list, and we're going to go through this process here to figure out what does this delay represent. Does it represent a space? Does it represent a dot? Does it represent a dash? Does it represent some kind of other separator? And all those separators are detailed here and defined. The logic here is pretty simple, but the one thing that's a little tricky is this guy right here, in which you see this kind of thing appears all over down here. What this is it's the notion of a threshold, or just we're using the average value of the two values as a threshold. So what that means is that we're going to, let's do an example. We have our dit, which is 1 up here, and our da, which is 3 times that, or just 3. So then, I'm just going to type here real quick. We have 1, and somewhere over here, we've got 3, okay? What we're going to do is we're going to come into the middle of them, or compute the average value, which is 2. And then we're going to have 2 be our dividing line between 1 and 3. If we record a time value that's less than 2, then we're going to treat that as a dot. And if we record one as greater than 2, then we're going to treat that as a dash. The reason that we do this is that it's very, very difficult to hit 3 seconds right on the mark. In fact, it's difficult to get within half a second of that. So it's very helpful to have this threshold, and it makes it much more robust. And we do similar things for all the other things that we're looking at, such as the space, which is waiting for 7 seconds with it released, and the such. So just look through this logic, make sure you understand what all these ifs and elses are talking about. And then here we are just pretty much building up a string where we come through, we have our word, we add dots and we add dashes and we add separators. And then once we have found a new word, once we finish the word, we get it and we have found a space, then we stick it onto the list. And then at the end, we return that big list, la-di-da. So coming to our decode function here, this is just going to take in the list of Morse code words that we generated with the last function, our interpret delays function. and it's going to return a list of, well, not a list, sorry, one single string of English or Latin characters, including spaces between words, like this wonderful sentence, at E. You can imagine what kind of scenario that would be. So first we just start off initializing our message as an empty string, and then for each of these words in our word list, we are going to pretty much not do that much. The nice thing about Python is it makes this process really dang easy. So call this split function, and I would recommend Googling this. Pretty much what it does is it takes in a string, well, it doesn't take in a string technically, but it applies an operation to this string, which word is a string. And it's going to go through here, and as soon as it hits the separator character, oh no, changing my code, specified by sep, it's that. As soon as it hits the separator character, it will then split that off into a new string and then return in a list of strings. So what this does is it splits our words separated by slashes into a list of characters. And then we are going to, for each of those characters or each of those letters, and it stores that in letter list. And for each of those letters, we are then going to do this fancy Morse to letter thing, and this is magic. We'll talk about that in a moment. And then it just adds it onto our string here, and we eventually build it up to be like this, and then we return it. I will note for morality's sake that this is not the most efficient way to iteratively build a string like this, but it is the easiest to understand. And then once we're done with that, this will, here we go. It will return that message out to here, and we will print the message. And it does work. And I will probably show a little bit of a demo, maybe. So then, what in the world is this guy? You can see, if you're rather astute, it kind of looks like you are referencing an array, or not array, sorry, a list there. And you would be correct. That is the syntax for accessing an element of a list. However, the thing to notice here is that when you access an element of a list, for example, if you have A as a list, and we're going to define A to be 1, 2, 3, and we wanted to get the element of A indexed by 2, we would say A of 2, which is of course 3, because our indexes are at 0, 1, 2. So it is not a list, however. It is this wonderful thing called a dictionary. And a dictionary is very much like a list. However, and I would recommend Googling it because I'm not going to take the time in this video to fully explain the topic. But what a dictionary does is it's kind of like a list where we have our list, 1, 2, 3, okay, and it's just kind of defined as, to get at this one, you would go A0, and to get at the next one, you would go A1, because they are indexed by integer numbers, or not, actually, yes, integer numbers. But dictionaries, on the other hand, specify keys and values, where we have A and the associated which is our key, and the associated value is this string dot dash. And what that means is that if we want to get at dot dash, rather than specifying a number, we would do letter to Morse A. And rather than having indexes, each of these things is kind of referenced by the value that you supply. So you could, for example, write a pointless dictionary that is indexed by 0, 1, comma, 1. Ooh, this is hard to type. 2, comma, 2, 3. And this is in fact exactly the same as our 0, 1, 2 guy. Oh, no, it's not because I typed that wrong. That's 1, 2. Oh, no, it is. No, that's different. What I had typed before. Anyways, so these are exactly equivalent in a good number of ways, or at least they're conceptually the same. Because here we have 0 points to 1, 1 points to 2, 2 points to 3, and similarly we have these, which this is the index 0, index 1, index 2. Anyways, Google it. That's a brief crash course. And so what this allows us to do is allows us to map, and I use that in the most precise mathematical way, A's or characters, Latin characters, to Morse code strings. And in fact, I copied this off of the internet and I couldn't find a Morse code strings to characters one. So instead, I just put this little confusing compact line in here to flip the dictionary around and swap the keys and values. So that's a thing. And if you want to try and understand what this line means, you may. So what this dictionary does is we're going to plug strings of dots and dashes into it, and it will give us back the characters, which we then stick on our message. We return the message, and as mentioned, we print it. So just look through this code, try to understand how it's working, maybe copy bits of it off into another file, and see if you can figure out what they are doing. In general, read the comments. Also, pay attention to kind of the style in here, because while I'm not the best Python programmer, this is a well-formatted piece of code, I would say personally. So yeah, just try and learn as much as you can from it. And to ensure that this video violates copyright law, here is an outro from Bob Dylan.